important decisions. I'm also the incoming undergraduate curriculum chair, which means that I get to figure out what's going on actually with our curriculum. And I've been doing curriculum for quite a long time. I've been pretty heavily involved in curriculum development prior to RIT, at other institutions, and I've seen this at multiple levels, both at a very technical school like RIT, a less technical school, a liberal arts school, and also at the community college level. And you'll see that it's kind of interesting at the different levels as well. So first off, when we start talking about accreditations, what does it mean for a school to be accredited? If you're not familiar, if you're not in academia, this buzzword might not mean anything to you. It basically means that some independent reviewer has decided that your curriculum matches up to some required curriculum. Okay? In our field, ABET is the primary accrediting agency, and they have accreditations for computer science, IT, information systems, and the new one that we'll be talking quite a lot about today is cybersecurity. Okay? They have their own accreditation, separate accreditation for cybersecurity. I think it dropped, the final version dropped in May or June. Okay? Now, there's also designations, and this is something that a lot of employers look for in employee resumes. Are NSA designations, that their students are coming from a school that is a designated center of academic excellence. And there's two of these. There's cyber defense and cyber operations. Cyber defense being, of course, sort of the blue team generic information security designation. Cyber operations being NSA's designation for a school with a more red team focused orientation. And as Chaim and I spoke last year, this is, when we say red team, it's really .gov red team. Okay? You wouldn't see some of the skills that the cyber operations schools are generating as heavily used in industry. I've never seen an employer looking, for example, for knowledge of the Geneva Conventions. Okay? So how does curriculum come about? So the way curriculum typically comes about, ACM pushes down these some recommendations. Nobody has to abide by these. And for security, there's some good reasons not to abide by these, since particularly for computer science, there's not a heavy focus on cybersecurity. For a computer science degree, you only need 3 to 9 lecture hours on cybersecurity during an undergraduate degree. That's a little crazy. However, these recommendations typically form a basis for the ABET accreditation requirements. Now, ABET accreditation, it's something that you have to have, I don't want to say have to have, but it is the standard for academia. And a lot of schools don't have it for many reasons. One being that it's a significant time investment to get this kind of accreditation. It's typically a multi-year process. But also, it's largely for marketing. Okay? It's largely so that you can ask yes when parents ask, so that you can say yes when parents ask if the school is accredited. Okay? So those ABET requirements come from ACM recommendations. They come from a little bit from industry. If you take a look at who are on the boards creating these, it's largely academics, but you will see somebody from industry from time to time. And these requirements, both these recommendations and requirements, end up coming into play when schools actually go and implement these programs. So schools look at these ABET requirements and say, yes, we're going to do them, no, we're not going to do them, yes, we'll do some of them. Similarly, they say, yes, we're going to try and adhere to ACM, no, we're not. We might do some hybrid, and that's how a school actually gets their curriculum. Okay? Industry has some play there, but as far as the actual program implementation, industry's influence is usually, you have people asking if your students, the students graduating, know, insert buzzword here, right? Whether it be cloud computing or big data or whatever. And after employers ask that question frequently enough, the school starts to teach insert buzzword here. Okay? So, program assessment is kind of the name of the game in academia. This is where a lot of work gets done. And what we want to do is we want to make sure that for these for the accreditation designation that the program is actually doing what it's supposed to do and teaching students what it's supposed to teach. So typically this starts off with, in the upper right-hand corner, with developing and revising learning outcomes. So you have to start off creating some learning outcomes that you expect your students to meet when they graduate. You develop some metrics, some assessment tools to determine if they are actually meeting those outcomes. Okay, if they're actually learning the things they're supposed to learn. You observe whether or not they're supposed to learn. You take a look at the data, see if you should either revise your academic content to help them meet their, do better at meeting the outcomes, or else you revise your outcomes sometimes. Okay? So this drives a lot of curriculum. Okay? Ideally, these learning outcomes should be reflected in particular courses and particular coursework. The way that this is often done is by having assignments in courses that the grades of those assignments are then used as the metric to measure the particular learning outcome. Okay? Most schools, particularly those that are accredited, you have to track these metrics over time and make sure that over time your students are learning the things that you say that they're going to learn. And those learning outcomes also come out of the accreditation and designation material. So most of those accreditations and designations have some generic learning outcomes that we'll see in a minute that you're supposed to then kind of adapt to your particular environment. Okay? So that's the background. And looking at how we compare programs, I want to talk about a couple of different metrics for comparing programs. One of those is going to be adoption rates. So when we look at accreditations and designations, it's interesting to compare how often are these accreditations and designations actually sought and or awarded. Okay? This is a little bit of a soft metric because it doesn't necessarily, because there's some confounding variables. It doesn't necessarily address whether or not particular program types are more prevalent than other program types, nor does it account for the ease or difficulty of acquiring a particular designation or accreditation. Some of these are easier to get, some of these are harder to get. NSA, the process is typically a little bit easier. ABET is an enormous amount of work. Okay? So we'll talk about required technical content. We'll look at some base skills and see which of these accreditations and designations actually require learning these skills. We'll take a look at non-technical content, but still related to security. And then we'll take a look at the kinds of skills that are actually measured in the learning outcomes, right? Because at the end of the day, what's actually measured in the learning outcomes, that's going to be the most heavily influential thing for curriculum. Okay? So let's take a look at adoption rates first. Adoption rates are interesting. By far and away, the ABET Computer Science accreditation is the most widely adopted. Now these numbers are international numbers. As far as I'm aware, NSA doesn't do international designation. Only ABET does that. So it's a little hard to compare. ABET, including international schools, has 661 accredited CS programs. That's huge, right? And I would say that's probably because computer science is the most widespread form of degree. Okay. IT internationally we see 72. Information systems we see 109 internationally. So quite a lot less. Okay. For NSA we've got 154 and that's for the defensive one. For the offensive designation, only 20 schools have that at the moment. Okay. So I think this is a little bit interesting. It does show that computer science is where most people are getting their technical content, or at least where most schools are seeking accreditation or designation. So when figuring out, do these particular programs have appropriate levels of security, computer science is going to be one that we want to pay attention to. IT seems to be sort of the one where I would kind of, the ABET program where I'd expect to see the most security. It's also the least sought designation, or at least the least awarded designation. There is the CSEC designation, or the CSEC accreditation, which is brand new. As far as I'm aware, no one has it yet. And that's probably because it was only finalized a few months ago, and this process typically takes years. I would expect to see schools actually getting this accreditation 2 or 3 years out from now. Okay, so when we talk about content metrics, one thing we're going to look at is it required? Okay, is this required content or is this elective content? Or is this not addressed at all? One of the things, and we'll talk about instructional hours, so I attempted to categorize how much time is dedicated to a particular topic, but in these, in the curriculum, there's no clear, they don't specify the number of courses or number of credit hours, so it's really, this is a judgment call on my part. Feel free to go back and look at this and disagree with me. Okay, so I said there's a significant amount of content if greater than 65% of the time is spent on this topic. There's a moderate amount of content if it's between 35 to 65%, and there's a casual amount of time or sort of casual mention of this topic if it's less than 35%. Okay, so again, feel free to disagree with me on this. Go back and look at the curricula yourself. You may have a different judgment call than I do. And finally, and this is the really important one, is this topic mentioned in learning outcomes, right? Because that's the thing that actually gets measured. Okay, so what do these learning outcomes look like? So here we have the ABET learning outcomes, and right off the bat, I mean, this is of course a lot to read, but right off the bat, looking at a lot of these, it's ability to apply, ability to analyze, ability to designate it. In only one location do we actually see anything about implementation, about actually sitting down and doing something in front of the keyboard, right? Okay. These are generic learning outcomes that apply to all particular programs, and there's absolutely no mention of security in these. Okay. So a few more. Again, ability to communicate, ability to analyze, and so on, but no mention at all of cybersecurity in any of these generic learning outcomes. Furthermore, only one of these has any hard skill. For the actual curriculum, there's a lot, okay? To sort of boil this large amount of text down, for the computer science curriculum, ABET wants you to learn algorithms and complexity, CS theory, some programming, exposure to architecture and organization, and then they want you to do pretty much a large end of the semester project, or end of the degree project. There's some math requirements, there's some math requirements, there's some science requirements, but there's no actual security requirements in the ABET-CS curriculum. Okay, again, not terribly surprising. So the CS curriculum has, again, some additional learning outcomes that go beyond the generic ones I just mentioned that are also ability to apply, ability to design. I guess there is development could be, depending on how it's interpreted here, could be a hard skill, but I think it's probably, since it talks about developing principles, I think it's a little bit softer. Okay. For the IT curriculum, so this looks a little bit harder. We have system administration, system maintenance, integration, and so on. But again, there's no, security is never called out. Okay? Certainly if you're going to be a good sysadmin, you should know something about security, but it's never explicitly mentioned in any way. That should be IT learning outcomes. So for the IT learning outcomes, again, no mention of security. In fact, only one of the IT learning outcomes has any hard skills as well. Okay, and that's the ability to effectively integrate IT solutions. Okay, everything else is assist, understand, identify, analyze, and so on. For the IS curriculum, it's even vaguer. There's less detail. There's even less detail provided for information systems, and their learning outcomes are specific learning outcomes are reflective of that. An ability to understand, or an understanding of, and ability to support the use, delivery, and management of information systems within an information systems environment. What the hell does that mean, right? That is so vague that almost anybody could, I think, meet that learning outcome if they've taken any computer science, any single tech class. Okay? So that's the traditional ABET curriculum in a nutshell. There's very little security and very few hard skills in learning outcomes. Okay? For CSEC, we have a very high-level view of the ABET-CS curriculum, which is brand new. And in looking at this, it looks, if you spend any time looking at this, it starts to feel like something else that is already very familiar to people in the cybersecurity space, and that's CISP. This feels like a group of academics sat down and reverse engineered CISP. Okay? Which I don't, not to get into whether the debate about whether CISP is a valuable certification or not, it is what it is. But it is interesting that a group of academics sort of came up maybe independently with a similar body of knowledge. Now I do want to dive a little bit deep into what this looks like. So each one of these knowledge areas has a number of different components to it. So we're going to do a deep dive into the software security knowledge area, because I think that's one of the most interesting areas, and it's one of the places where we've seen traditionally in academia the least amount of focus on security. Okay? If you have spent time in academia, security usually gets pushed into operating systems courses and networking courses, where you see discussions of firewalls, discussions of cryptography, and so on. But you don't see a lot of security content in programming courses, which is unfortunate, because that's one of the places where I think students really need the most. Okay? So we'll do sort of a deep dive into software security. So the CSEC curriculum has a list of what they consider essential topics. Okay, fundamental design principles, including least privilege, open design and abstraction, security, being able to define security requirements, implementation issues, which that's where we're going to continue our deep dive. If we're going to find highly technical content, I think that's where we're going to see it, is in the implementation issue. Static and dynamic testing, configuring and patching, and ethics. So let's dig further into implementation. So the implementation topic within the knowledge area of software security has a number of subtopics, okay, or subtopics, I guess we're at. And honestly, these don't look bad. Okay, so one of these subtopics is validating input and checking its representation. And in particular, they call out checking bounds of buffers and values of integers. They don't explicitly say looking for overflows, but that's there. I mean, that's, I think, what they have in mind. And checking input to make sure it is what's to be expected. So these do feel like hard skill requirements, right? It's not no to check for buffers, it's check buffers. It's not no to check inputs for what they're expected, it's check the inputs. Okay? And this continues on. There's a number of these ones, but I think this is the one that I kind of want to focus on right now. There's another 5 or 6 of these subtopics with varying technical skill. So if we take a look at that particular subtopic, and we start looking at what learning outcomes the CSEC curriculum expects students to actually meet, we see a lot of soft skills. Explain why input validation is necessary, not validate input. Explain the difference between pseudo-random numbers and random numbers, not generate things in a cryptographically secure way. Differentiate between secure coding and patching, etc., not actually do secure coding, and describe a buffer overflow and its security implications, not like write a fuzzer to see if a buffer gets overflown. Okay? So it's know that, not know how, that these learning outcomes are looking at. There's also high-level learning outcomes for the ABET-CS curriculum too that stack onto those general ones we talked a little bit about earlier, where it's looking where it says apply security principles and practices to the environment. Okay, that's pretty broad, right? What does it mean to apply security principles to an environment? That can mean a lot of different things to a lot of different people, particularly when you consider the fact there are few CSEC programs in general. Usually this CSEC gets crammed into some other academic area. So applying security principles in computer science is very different to applying security principles in IT. So what does this actually mean? If an employer is looking at this, what skill can what can the student actually do for applying their security principles? And the ability to analyze and evaluate systems with respect to maintaining operations in the presence of risks and threats. Okay. again, that's a little bit broad, and it's certainly a soft skill, not a hard skill, right? This could range, you could meet this by looking at at a very high level network map and analyze, does the network design look good? Or you could actually analyze it by looking at firewall rules and saying, do these firewall rules make sense? So this ranges from this particular student learning outcome could either be a very soft skill or a very hard skill. Okay? So that sort of wraps it up for ABET. Let's do a quick dive through NSA. So NSA has a lot of stuff that students have to take. It's got a 2-year and 4-year core. And again, right off the bat, this looks very technical. Okay? So we have IT system components, networking concepts, system administration, crypto, kind of the things that we saw scattered around a little bit through ABET, condensed all into one place. And I think that's a good way of viewing the CAE-CD. Okay? There's also a number of electives, and this is why I think we see so many CAE-CD schools in comparison to CAE-CO schools. Okay? Schools have to be able to offer all of the core courses, or all of the core topics, and they'll have to only offer a very small subset of these electives. Okay? So you could actually have some schools, in business, for example, who teach cybersecurity management and planning, maybe security risk analysis. Somewhere in here, I think there's a forensic accounting class, and get a CAE-CD designation. Okay. Or you could go very technical on the IT side and have advanced network technologies, virtualization, wireless sensor networks, or you could go very theoretical on the computer science side and have algorithms, data structures, intro to theory of comm, and still get this designation. Okay, and every one of these KUs, every one of these knowledge units has its own set of learning outcomes. So here we have the I think this is for the operating systems. I think this is for one of the advanced networking classes. And right off, and again, we see some highly technical content here. Okay, develop programs, that's a hard skill. Okay, implement new functions in an OS kernel, that's a hard skill. That's not a know that, that's a know how. Write programs, again, know that, not know how. Okay. So this pattern also holds true for CAE-CO in that every one of the knowledge units that I'm about to mention have their own set of requirements here. So for CAE-CO, the knowledge units are low-level programming, which Chaim and I have talked about before, that has some insane requirements like implementing your own TCP/IP stack with no external drivers. Okay, that's crazy for undergraduates, right? Software reverse engineering, OS, networking. I mean, this is not bad. This looks like a lot of technical content, and we see they're elected. The CAE-CO electives. I forget exactly how many of these have to be able to be taken. I think it's 6 or 7, but I might be wrong on that. Again, most of these are very technical. We only see a few non-technical ones, a few non-technical knowledge units like risk management, UX, user experience, and human-computer interaction. Interestingly, offensive cyber operations, as it's defined here, is not hard skill, it's soft skill, because it's mostly about process, not about actually sitting down and hacking things. Okay. So now that we've talked about all these curriculum, how do they actually compare? Okay. Let's sit down and get to the actual technical content, non-technical content. So taking a look at, let's start off with programming. So is programming required? Yes, in most cases. Programming is required in most of these cases. The only place you don't see programming explicitly required is ABET-IT, ABET-IS, kind of ABET-CSEC, in that they have programming content, but they don't necessarily have the learning outcomes associated with it. And it's only programming specific to security and specific to secure coding. It never says you actually have to sit down and learn a programming language from start to finish in any way. Okay? Now, the only place we actually see learning outcomes to measure how much programming students are actually learning are in the NSA designations. So ABET-CS, you have to be able to do a lot with algorithms. Okay, you have to know a lot about algorithms, for example, but at no point does ABET-CS ever actually say you have to be able to sit down and implement algorithms when you're done. That seems like a big disconnect. As a point of comparison, for the NSA designations, it actually explicitly says you need to be able to sit down and implement these algorithms, a specific set of algorithms described in the knowledge unit. So for networking, do students have to learn networking? In most cases, no. Well, actually, in half of the cases, no. So interestingly, ABET-IT does not have networking as a skill or as a required content area. Okay, yeah, I know, that's a shocker, right? You do see it in ABET, in the CSEC 2017. There's a small amount of content in that, but it's largely non-technical. There are learning outcomes, but they're soft skill learning outcomes. For NSA CAE-CD and CO, there are technical learning outcomes here as well. So yes, you have to take networking, and yes, you actually have to be able to do things like sit down and configure a router, or sit down and write some kind of network program by the time you're done. Okay. System administration. So ABET-IT has this. CS, IS, no. Honestly, I didn't really expect IS information systems to have a lot of technical content because it's a more non-technical area. Okay. CS, it's not surprising that you don't have to learn system administration as a CS student, but it does mean that a large portion of, we saw earlier in this, we saw that graph earlier where the highest number of students graduating are coming out of accredited CS programs, which means they come out not knowing anything at all about how systems actually run. Okay. It is, again, it is required content for CSEC 2017 for the NSA designations. And the NSA designations have learning outcomes that actually track whether or not students are learning system administration. And crypto, we see basically the same pattern holding for crypto. Okay, so CSEC and NSA requires crypto. There aren't many learning outcomes. Actually, this slide has an error. There should be, yes, there are learning outcomes for crypto and CSEC 2017, but they're soft learning outcomes. So it's about cryptographic algorithms. You'd be able to select an appropriate one, not actually sit down and, for example, encrypt a file, okay, or sit down and actually set up TLS, okay. So let's talk about non-technical content. Risk, I think, is an interesting area to start, particularly, I mean, that was something the keynote speaker mentioned as something that we should be paying attention to. So, do students have to learn about risk? For most of ABET, no. The big surprise here is that information system students don't have any content related to risk, which I think is a little bit surprising. Interestingly, if you look at the ACM curriculum, the ACM Information Systems curriculum, there is risk in that, but somehow that risk requirement didn't go from the ACM recommendation to the ABET requirement. Okay, it is required in CSEC 2017. It is not required in either of the NSA designations. However, it is elective content in both of them, and they have learning outcomes for that elective content. How about security policies? Do students need to understand security policies? So it is a requirement for CSEC 2017. It is a requirement for CAE-CD, but that's it. There are learning. It's an elective, I think, in the risk management area of CAE-CO, and there is a learning outcome associated with it. But there's it's not. There's no explicit. What do I say? There are. The way that it's worded, it's hard to assign a set amount of instructional hours to this, but it's very minimum. Okay. So presenting. do students have to be able to present, right? I mean, that's something I hear from employers all the time. Students come out not being able to talk, not being able to discuss what they actually know, okay? And for the ABET accreditations, there are no presenting requirements. Okay, at no point does it say students actually have to be able to present their material. Now, there is a learning outcome here. It is vaguely defined. This is maybe a little bit of a charitable interpretation on my part, but it says there's a learning outcome, effectively communicate. That can mean a lot of things. So I gave ABET the benefit of the doubt and said, yes, this is, in order to effectively communicate, you have to present, but that's some interpretation on my part. It's not explicitly spelled out. Okay. It is required in NSA and CSEC that students have to be able to present ideas, okay, but not in CAE-CO. And this pattern also holds for writing. Okay, so again, students have to be able to, so again we see yes as a learning outcome for ABET, but that's again because of that effectively communicate. So I'm interpreting effectively communicate here as present and write. Okay, but that's a judgment call on my part, and some other school implementing these, implementing curriculum to meet these requirements might be able to argue against that and avoid having a writing requirement for their students. For CSEC and for NSA, it is required. Okay, I think for both NSA and CSEC, there's a learning outcome where in one of the required knowledge areas where it says something about generating reports. Okay, so we see it there, we see learning outcomes. It's measured as a learning outcome in most places, but we see a disconnect as to whether or not there's required content to generate the knowledge for that learning outcome. Okay. Privacy is one of my favorite ones. Not surprisingly, we don't see privacy as required content in NSA CAE-CO. Okay. We don't see it as a required content anywhere else except CSEC 2017 and CAE-CD. Is it a learning outcome anywhere? The only place there are any learning outcomes related to privacy are NSA CAE-CD. That's the only place where a student's understanding of privacy or privacy-related issues is actually tracked over time. And my absolute favorite one is ethics. Okay? So we see ethics required everywhere, and there's a learning outcome everywhere. There are very few instructional hours, except in CSEC 2017, where every, I think 3 or 4 of the knowledge areas have their own special ethics requirements. So like there's an ethics section under software security, there's an ethics section under organizational security, and so on. And it's required in most places, okay? For the ABET curriculum, for CS, IT, and IS, there is a generic learning outcome that students have to learn ethics as it applies to their particular area. So again, I think that's overly broad. What the hell does that mean? Okay, it doesn't explicitly say what students have to know about ethics by the time they're done. Okay, it just says, I look at that and get the sense that somebody thought, yes, we need to cover ethics, but almost view it as a sort of a throwaway topic, which is unfortunate, and I think we're seeing, in the world at large these days, the fallout from our industry not considering ethics over time. Okay. The other place where this gets really interesting is NSA CAE-CO. So yes, there is a small amount of ethics required by the government offensive track. However, for example, it's a trivial amount compared to how much students have to come out of that knowing about law. And in fact, international law. So I referred to this earlier, but this is a place where CSEC students, for example, have to sit down and learn about the Geneva Conventions. I'm not so sure that I want, a freshly graduated student to have to be making decisions about whether or not something they're doing is a war crime. Okay. So in looking at these areas, this is sort of interesting. So let's now do a deeper dive, a quick deeper dive into the kinds of learning outcomes. Okay. So how these things track for kinds of learning outcomes is a little bit more interesting. So we see ABET trends towards soft skills, okay, right along the way. So ABET The ABET general requirements, 8 of the learning outcomes are soft skills. Only one of them has a hard skill. Okay? For CS, there are no hard skills. Only 2 soft skill requirements. IT does have 1 additional hard skill requirement, but at best, ABET's tracking at 1 out of 6. So if you consider the ABET-IT, if you add that to the ABET general requirements, we're looking at 12 soft skill requirements and 2 hard skill requirements. Okay, that's not great. Okay, and CSEC 17, so CSEC 17 has an enormous amount of knowledge units, that each of which have their own set of learning outcomes. So CSEC 2017, if you look at the knowledge unit level learning outcomes, there's, I'm ballparking here, but 400 or 500. So I'm not done reviewing all those yet. And they're a mix of hard and soft. It'll be interesting to see what it shakes out. I suspect it's probably going to shake out to be largely soft skills. And if you look at the CSEC 2017 generic learning outcomes, they're all soft skills. Okay, so two of the 2 are soft skills, there's no hard skills. NSA, on the other hand, the CAE-CD core, there's 39 soft skill requirements and 7 hard skill. So right off the bat, we also see a greater amount of granularity in the number of learning outcomes and in the kind of learning outcomes and the number of learning outcomes. So the curriculum has to be, there's certainly more attention to detail in the NSA curriculum. For the elective space, we've got 130 soft skills and 50 hard skills, which is, I think, an interesting result. So the elective, we've got a pretty good ratio of soft skills to hard skills as far as this goes. For CAE-CO, we have almost half of the, or actually almost a third of them, almost a third of the learning outcomes in the core are hard skills. And the same thing holds true for the electives. Okay, so the NSA designations seem to be much more hard skill oriented than the ABET accreditations. So some conclusions here. It seems like ABET, the new CSEC 2017 designation, does a much better job at addressing these broad security ideas, even if they do mostly focus on soft topics, than the other academic accreditations, right? So if you're going to go if you want to do security, getting a CSEC, if you want to be able to say or accredit, you're doing security properly, getting a CS accreditation doesn't make a lot of sense. Okay, you'd want to get the CSEC designation, or the CSEC accreditation. I think that the CSEC 2017 indicator is the way that the curriculum is set up. It's an indicator that ABET wants to do a better job at security, okay? But it wants security to be its own discipline rather than integrated tightly into other academic disciplines, which I think is a strategic mistake, right? I mean, if we look at how industry is headed, I don't know that siloing here is the right approach. Okay, and I think the accreditation is structured in a way that's a little bit contradictory. So I think ABET is trying to say security should be its own discipline, but on the other hand, the accreditation is broadly structured in terms of the learning outcomes, so that it's mostly soft skills, and sort of any of the 3 areas could probably go and meet the learning outcome. Develop some program-specific learning outcomes that match those soft skill learning outcomes, and get the CSEC designation. Much the way we see the community discuss CIS, right? You can have a technical background to go for CIS, or you can come from a highly non-technical background and also do it. Okay. ABET-CS, by far it's the most prevalent accreditation. It's also the one that has the fewest core security skills. So it's the place where we saw, I think, the most, it's the place where we saw overall the most no's. Okay, with the exception of maybe information systems security, which doesn't necessarily track the ACM recommendations. The cyber operations, we see a lot of technical skill in the cyber operations, not a lot of non-technical skill, okay? Not a lot of non-technical learning outcomes. The CAE-CD, I think, is really broad, but it also has some of the best, I think, learning outcomes in relation to technical versus non-technical. So, if I were gonna sit down and say which of these would I want to see my kid go to, I would probably pick NSA CAE-CD. Yeah. So, references, and at this point, we'll open it up to questions.
Okay, so the big question, has anybody created a crosswalk across the different accreditations?
I'm not sure what you mean by crosswalk, like a path to go from CS to CSEC?
No, a path that matches the learning outcomes in one to the learning outcomes in the other one.
The CSEC 2017, I don't know. Oh, so the question was, has anyone created a crosswalk mapping CSEC learning requirements to the other learning requirements? Is that fair?
Yes, that's
Okay. No, not that I've seen. That may, I wouldn't be surprised. I wouldn't be surprised to see some internal documents from ABET that have done this, but there's no public information on that I've seen.
And the follow-up, are you going to provide these slides?
Sure. Yeah, I've got no problem providing these slides. I don't. Yeah, I'll figure out a way to make them public. Yes.
Yeah, so can you build a CS degree that fits the requirements of the NSA CAE accreditation, or does it need to be a separate degree?
So, yeah, the answer is yes. No, not a problem. So the question is, can you build a CS degree that meets the NSA CAE-CD requirements? Is that what you?
Yep.
So the answer is yes, you absolutely can. But you'd have to see, I think. So first of all, you do see this. There are schools, the CS programs, that have NSA CAE-CD. In fact, if I remember from the research we presented last year, I think the majority of the NSA CAE-CD are actually in computer science programs. But as far as doing a deep dive into the curriculum, I would expect to see a higher than normal amount of IT content in those classes, or in those degrees, rather than a lot of what has been traditionally the focus of computer science, which is more theory and algorithms.
Are you worried about cyber degrees pigeonholing students that might otherwise get CS degrees? Because I mean, when you graduate with a cyber degree, say you can go get cyber opportunities, but then maybe you might get passed over for more general CS opportunities. Does that concern you at all?
Yeah, so I think that's an interesting question. So the question was, am I worried about a degree in cybersecurity pigeonholing a student so that they can't pursue non-cybersecurity opportunities later? So I think, for example, the NSA CAE-CD designation would prepare a student to do a number of IT-related things besides cybersecurity. So someone with that designation, someone coming out of school with that designation, it would depend heavily on what those if you pick 5 or 6 out of that huge table of electives, it would depend on heavily what that school picks out of the table of electives. But I'm really not that concerned for that particular designation. I think it would prepare students to go for become system administrators, be network administrators, and so on. Programmers, I don't know. Maybe it depends on, again, it depends on those. For the CSEC 2017, yeah, you're absolutely right. That I think would tightly focus a potential student on cybersecurity opportunities, but that's something that they should be aware of when they make a choice to go for that major.
Just a comment on that. If from a hiring manager's perspective in cybersecurity, if you have the programming skills in any solid language that's widely used, you're going to be okay on the cybersecurity side. We're looking for people that can code. We're not necessarily looking for anything specific as it comes to languages. I mean, a good solid Python coder to us is just as good as an old school Pascal programmer. If they know Pascal, but don't know Python, we know they can learn Python and put it to work. You do a lot of automation with skills that do that. So just as a comment, just if you like coding, if you're a good programmer, just work hard on what you like, and you can morph into something else when it comes to cybersecurity.
Yeah, so that's absolutely true, and that's what I hear from pretty much any employer, is that as long as you understand the fundamental concepts, That's the important thing about programming, more so than knowing, insert buzzword here, right? So I think that's what makes the programming slide a little bit more interesting in terms of how is programming taught in these areas related to cybersecurity. So programming is heavily focused in, we saw learning outcomes for that in NSA CAE-CO. We saw required content in CS, but not much else. Okay?
I have sort of a non-curriculum question.
Sure.
Back to the accreditation. And I know a lot of these accrediting agencies have restrictions on teaching loads, research balance for faculty. And as you know, a lot of private colleges, even more so now in the public sector, faculty are expected to teach 24 credits a year. And some of these accrediting agencies limit the number of courses the faculty can actually teach versus research. Do you have any idea or comment as to how these align with teaching loads?
So that's a really interesting question. I don't recall seeing anything about that in the NSA designations. The ABET, the public information, so the ABET process is really, really involved. It involves multiple trips by a reviewer to the school, and there's a lot of, I don't want to say requirements, but a lot of things that the reviewers look for that are not necessarily clearly spelled out in the documents you can download from the website. Okay? So on the website, I don't think there's, at least publicly available, I don't think there's too much about that, but I do know from experience that is something that the reviewers look for. Okay? And it would be an interesting metric to see how these programs compare along those lines. Certainly, it's, I think, a point of concern in general around academia that educators, I wouldn't necessarily say, except in community colleges, are required to teach that many classes. But in practice, pushing people to adjunct status has resulted in many people having to teach that many classes in order to survive. So I think that's an interesting point of concern. I would also say that at least for the IT-related concept, at least for the IT-related content, at the 4-year level and at the 2-year level, I would say a decent amount of faculty teaching IT courses are adjuncts. Maybe not necessarily professional adjuncts as the term in academia goes, but you see a lot of people who are system administrators or who are network administrators teaching system administration or network administration at night. Yeah.
Yeah, so do you think it's important to balance the social/theory, policy, privacy side with technical? Say there's people who are extremely technical and very interested in doing software reverse engineering or binary exploitation, and they don't want to learn about policy or law so much?
Absolutely.
Okay.
Yep.
And for what reasons?
Because I think, largely speaking, tech is viewed as something that is amoral, and that's just wrong, right? I mean, we see people making moral decisions all the time about how to use technology, and it needs to be. I think it's fair to view technology in this respect similar to how we view medicine. Okay.
So for that giant matrix that you showed of the electives that the NSA programs recommend, do they actually provide outlines for what they expect in some of those courses and electives?
Yes.
Okay.
Yep. In fact, I think I have one of those up here. So this is a sample. I think this is actually this is the learning outcomes from one of those. And you'll see also something comparable for content. So there's up here there would be content that has to be taught in this class, and then here's the learning outcomes from someone who went through that content.
Cool.
So it's much more granular than anything in ABET.
Cool.
Other questions?